Is it like question based session, or is she or he explaining the lectures there?
I mean, she
Pardon?
was like explaining the lectures, I guess. She couldn't complete it all because like there were doubts being asked. She wanted
Hmm.
to discuss a few problems as well, as far as I remember.
Okay. So I'm also thinking to explain the lectures only. I will try to explain like in more depth and all. And so in between the lines, if something is missing, yes.
बस ऐसे ज्वाइन कर दिखाओ
Yes, any doubt? Someone was speaking.
Yeah, I think they don't know they're online. You can
Okay.
mute them if you.
Yes, sure. Okay, so we'll start. We'll not waste much of the time. We'll start the session. So how many more TAs are there?
I'm aware of only you and the lady before on Saturday.
So let's make the session a very interactive one. It should be like two-way session. You should ask me. And first of all, like someone was asking me about the video lectures also. Uh, please mute yourself first. This is my request. Please mute yourself. Everyone mute yourself. If you have any doubt, raise your hand. I'll ask you, like I'll call your name and you can speak, because there are students, so it shouldn't be chaos here.
Ma'am, you're the host. You can mute everyone by clicking on the
Yes,
screen.
yes. I think it's fine now. Please don't unmute yourself unless or until I am saying, or you can write in the chat, raise your hand if you have any doubt. Yes, Shrutika, ask the doubt if you are having. Only Shrutika, please unmute yourself. We have to start it.
Good
Yes.
evening, ma'am.
Good evening.
Ma'am, yesterday I have enrolled in this course, Introduction to ML. So I don't know much about the videos and all you all were speaking about.
Okay. So video lectures are provided to you in the Swayam portal. You can see that. The video lectures week 1 and week 2 are provided. So we are also going to discuss about those video lectures in more detail. So you can attend today's lecture and afterwards go through them, maybe.
Ma'am, already 2 weeks have completed.
Yes. This is my first lecture, the TA's first lecture, but they have actually completed the 2 weeks. They have submit it's fine. Like only they are the recorded videos only. Today is the live session, first live session from my side.
Ma'am, ma'am, in that list it was shown that like afterwards it will start. So I thought it
No, they
haven't
have only
started.
provided only the recorded video lectures of 2 weeks. It's fine.
Okay, ma'am. Ma'am, every week this doubts clearing section will be there.
Yes. Every week from 6 to 8, the doubt clearing session will be there. Okay.
Okay, ma'am. Ma'am, assignment, how should we do the assignments and all? Like you all will say.
I'll tell you everything. Don't worry. Like assignments will be there. You have to submit the assignment till the due date. The MCQ problems will be there. We'll also discuss about the questions and all. I'll explain the whole lectures and all in much detail. And if you are having doubt, you can contact me on my mail ID. This is my mail ID. I'm providing you. I want
Yes,
that
ma'am.
everything should be clear by like for you guys. There should be no doubt on your side, and the recorded videos will be provided on the YouTube channel named Prableen Kukreja. Okay, her note, please can you write in the chat or ask the question later on? Maybe we'll discuss the doubts later on, because already 5-6 minutes are over, and I have to cover the things.
Ma'am, it's CS21D503, no?
Yes.
Yes, thank you, ma'am.
Okay. So let's start the session. I'm sorry for being in so hurry because I don't want that things should lag behind. Let's start with an important part. So let's start with very basics. I'll try to cover from basics to advanced, and I'll try to cover the mathematics part. Like, wait a second, is the video being recorded? Yes, yes. So I'll try to cover everything from basics to advanced, and the mathematics part also, which are not like the steps are missing or you are unable to understand. So first of all, let's start with what is machine learning. Anyone? Please write in the chat because there are so many participants. Yes. What do you think? What is machine learning? In easy words.
To train a machine for like how a human understands, like you have to train it to a machine by using a lot of data sets.
Okay. Anyone else? Write in the chat. Make this session a very interactive one. Class of algos dealing with learning patterns in data like human does. Exactly. Ability of machine to learn to do a specific class. Train machine using data. Exactly. You all are correct. Like machine learning is like training the machine. It is a subset of AI. Exactly. It is the ability of the machine to do a specific, to learn the specific class, enabling computers and machines to imitate the way human are doing. Exactly. We have to imitate the way human are doing. We have to make the machine learn it. So in easy words, I can say it is the field of study. And I'll also upload these, don't worry, these notes as well. And I'll share with you the drive link. Field of study that gives computer or any machine the capability to learn without being explicitly programmed. So as you guys have also said that I don't want the machine to explicitly program to tell them everything. I want that the machine should learn by itself. It should learn. It should have the capability to being learned without being programmed. That is basically machine learning. Can someone of you give the example? Like what can be the basic example like you guys use in your daily life about machine learning? Can someone give 1 to 2 examples? Spam or non-spam classification, Netflix movie recommendation. Exactly. So if I talk about Rahul, as you have said, Netflix movie recommendation, how it works, the recommendation system, Charlie, how it works, Blinkit recommendation, email spam or not spam. Okay, it's classification, machine learning also. You all are saying about recommendation. Someone is saying Blinkit, someone is saying, yeah, most of you are saying about recommendation by our watch history. Are you sure it's by our watch history? Someone can explain about this recommendation? As you have given the example of recommendation, please can someone explain about this recommendation? What do you mean by this recommendation thing? Maybe it can be any recommendation, shopping site recommendation, YouTube videos, Netflix videos. What does this, how recommending, how they are recommending?
It will look at the videos or the movies or the things we've already clicked on, watched, and there'll be classifiers on it. So next time they'll recommend us different movies with the same classifiers.
Exactly. So it's basically, obviously, it's not like any person or any team is sitting or looking at what is the particular user doing. So it's not like that. The team is watching you. It's like machine is learning by itself by seeing your pattern. How like if I talk about shopping website, I log in and I check one product, and another time when I log in the same a shopping website, they'll recommend me the same type of products because machine has learned about what is my behavior, what I need basically at that time. So that is an example recommendation system. Or as you said, email spam or not spam, that is also a type of machine learning. So many examples you have given. Let's see the formal definition now. Okay, this was a non-formal, like what is machine learning. Now let's see a formal definition, which is also given in the class as well. So machine or agent is said to learn from experience with respect to some class of tasks and performance measure P if learner's performance at task in class as measured by P improves with experience. So I have given a long definition. So let's split this into parts and try to understand. Machine or agent is learning from experience. Let's first understand what do you mean by learning from experience. Split this into parts. Let's see. So this is the definition of machine learning. So to learn from experience. Machine is learning from experience. What do you mean by this? Learn from experience. Can someone tell me?
Like you got previous data and like in the case of usual machine learning algorithms, you'll have previously found data and their corresponding predictions or the classes that the particular data points belong to, and you let the machine go through it and gauge insights from that.
Yes, exactly. I'll come to Vishnu. I'll come to supervised learning. I'm not talking about that. As you have answered before, that machine is learning from past data, or Sam has accurately answered that, or Chetra, historical data, learning from, okay, it's not learning from trial and error, Ansh. I'll come to that learning. So basically, learning from experience means learning from historical data, as many of you have mentioned, or learning from observation, I can say. So previous research or historical data, machine, whatever has happened before. So we are learning from that experience, or we are learning from our observation, which we are looking now. So that is basically machine is doing. Machine is said to learn from experience, okay, with the past data or with the observation. Now read next. Let's read next with respect to some class of task. So with respect to some class of task, so it's like the task can be, as you have mentioned, that the task can be classification task like spam or not spam. So some task is given to us. That is, let's say it as T. We are learning from experience to learn some tasks. Suppose, like, okay, so that is what we are doing. Like spam, like email, we are classifying it spam or not spam. That is basically learning. We are learning what we are learning. We are learning the task. How we are learning? We are learning from experience. Like historical data, we are seeing that, okay, this email was containing these words, so that is why it was spam. So that is what we are trying to do here. Next line, let's read. Performance measure P. And okay, and performance measure P. What do you mean by performance measure here? This was the first thing. Second subpart. Third, performance measure P. What do you mean by performance measure? Why we need it, first of all? Why we need this performance measure? How well it performs? Yes. So how accurate it is? Yes. So basically, if I'm learning something, if I'm doing something, I need to know how accurately I'm doing, how to compare with the previous. Yes, basically how we are measuring the success, I can say. Like whether we are doing correct or not, we should have some measure here. So that is what the role of the performance measure. As I can say, the marks in the exam want to quantify the well the machine is learning. Yes, Tanisha. So basically, what we are doing, we have to measure their success. We have to measure how accurately, how good we are going. So if we are going, we are learning something, accuracy, yes, exactly. It can be accuracy's type of a performance measure. So there can be various performance measure as well. Uh, Someone is saying screen is blank. Is it so?
No, ma'am, it's visible.
Okay. It's fine. Okay, let's. I think it's Problem
If
at
you
all.
stop sharing and start sharing again, maybe it'll come back for them.
So, so we have some performance measure. And now what's the next line? If the learner's performance as task in class as measured by P improves with experience. So what it is written? If learner's performance improves with experience. So what do you mean by this line? If learner's performance improve with experience. So what they are saying is that by experience, by training, by learning, our performance is improving or not. If the performance is improving, it means that learning is actually happening. If the performance is not improving, which means that the learning is not actually happening. So let's now read the whole statement. What they are saying is machine or agent. Basically, we are learning from some historical data. We are learning from the observation with respect to some class of task. So I'm given a task. I'm learning from the observed data. I have to measure how accurately or how good I'm doing that. So, and one more thing, that the learner's performance, it should improve with the experience thing. Then only we can say it is getting the task is getting performance as per my performance metric, which means that learning is actually happening. Is it clear? Should we continue? Please pinpoint me if I'm going very fast or I'm going very slow.
No, ma'am, it's correct.
Okay. So let's go with the ML paradigms. First is supervised learning. Can someone tell me what is supervised learning?
Supervised learning is where we have like annotated as in like for classification purposes, else we'll have like continuous data for predictions.
So like actually you're saying either it's
Like a ground truth. We have ground truths or something.
Ma'am, it is like we are going to give the label data in supervised learning.
Yes, absolutely correct.
Supervised learning is when we are keeping a check on the algorithm or the machine if it is perfect, if it is performing according to us, and we are providing it all the datas and the labelings in the test in the
Training only.
Training data only. Yeah.
Yes.
Yes,
So
ma'am. Whatever giving our input, that only can take output as label data.
So all of you are mentioning label data, input, output. So let's try to understand it. Okay, you got to know what is machine learning. Now coming to supervised learning, as you have said in the chat also, everyone, that learning with the label data where we have both input and output, absolutely correct. So supervised learning is we are learning, or I can say there is input output mapping there, or there is labeled data there. Labeled data, you all are mentioning what is this labeled data, which means I'm given with the output as well. So output, I'll come to the training testing data in detail. Okay, maybe I'll tell you now only. I have some training data. Training data means I have some data from which I'm learning. So with that learning, I'm here given the output as well. Suppose X is there, Y is also there. This is my input, this is my output here. So this mapping is here, that this input correspond to this output. This input correspond to this output. So this mapping is there, this labeling is there. That is why you all are saying labeled data. So test, okay. So that is basically supervised learning, where input and output mapping is there so that we can predict output for unseen in. Okay, this is the training data. And what happens in test data? Training data is containing input output pair. What about test data?
In test data, we do not give the values of, we do not give the answers of X. For some unknown X, the algorithm finds out the value of Y.
Okay, yes, sure. So if someone is being confused about training and testing, there is a whole
टेस्ट डेटा पे ट्रेनिंग डेटा पे काम करते हैं, टेस्ट डेटा पे उसको प्रेडिक्ट करते हैं.
Yes,
और
exactly.
उसे क्रॉस चेक करते हैं दूसरे वाई टेस्ट के साथ.
Exactly. So we have whole data, training data. It is used to learn. We are making model learn from this training data, and some data we are keeping it like to check it, to verify that whether our model is learning, like whether our machine is learning correctly or not. That is by test data, testing purpose. So there I'll give the input, I'll not provide the output there. But where I'm providing input and output in training data, that is basically supervised learning. So can you give me some examples here again?
Ma'am, logistic regression, linear regression.
No, a real life example like. Yes, Sanj?
Email.
Email. Email. What email?
Ma'am, stock price prediction.
Stock price prediction. Okay. Yes.
Ma'am, in supervised learning, we first give the training data, training set for the machine or algo to learn. Then after we train it to the with reference to the training data, we test it with a testing set, right?
Yes.
Then this all happens. This all is a part of supervised learning.
Yes. Exactly. So supervised learning is like in training, we are giving both X and Y, input and output. The difference with the other unsupervised is in unsupervised, we are not giving the output. I'll come to that. Here I am providing that X1 is mapping to Y1, X2 is mapping to Y2. Like if I come to email spam or not spam, what I'm saying is this email one, which I have received, is basically spam. This email 2 is not spam. This email 3 is spam. So I'm giving this. This is basically training data. Like suppose 100 emails I have given. In testing one, I'll give some 5 emails and I'll ask the machine to predict whether it's spam or whether it's not spam. So when I'm giving both X, this is input, this is output. When I'm giving both input and output mapping, that is basically supervised learning. Got it? Ansh, is it clear? Okay. So basically
Yes,
we are yes. So we are being provided with the now supervised learning is of two types: classification as well as regression. I think we are going very slow. We have to cover much part. Okay, let's see. I want that it should be clear to you. So what do you mean by classification? What do you mean by regression? What's the difference? As many of you have told earlier only, but still.
In classification, we have like a category of output like just two truth and false. And while in regression, it is like a continuous output is there. There is a mainly technical values.
Okay. If I say it's not only truth or false,
मैम
you are
क्लासिफिकेशन में probabilitical basis पे करते हैं 0 से 1 ऐसे ऐसे या तो
Classification is discrete.
classification
Regression
is
is
all about
regression
predictor
में
category or level.
मतलब क्लासिफिकेशन में नॉर्मलाइज नंबर आते हैं, रिग्रेशन में रैंडम नंबर्स आते हैं, तो वो
Classification is all about predictor category or level, and regression is all about predictor continuous numbers or values.
Classification is quality-wise, regression is quantitative.
Ma'am, classification
has a
classification
discrete
is
values
discrete
or
and
outputs.
regression is continuous.
Okay. So you all are almost correct only. Like somewhat some are basically getting confused. So classification, someone said that it's truth or false. So we can have it's like not only this is binary classification. Like I'm having two number. It can be multi-class also. I can have multiple also classes like A, B, C, D. Whether it's a cat, whether it's a dog, whether it's tiger, whether it's elephant. I'm giving an image or NS data set. This is a data set. I'll make you work. I'll make you practically work also. Try to make you practically work. Like if will do linear regression, I'll make you work. I'll make you code also. So we'll come to this also. This is a data set like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we are predicting these numbers. So this is basically which category, which class it is belonging to. That is classification. It's not only true or false. There can be multi-class as well. So if I talk about true or false, it comes in binary classification. Like I'm having only 2 classes. I can have multiple also. Now in regression, as someone said that it's quantitative in number. Yes, it's actually quantitative. It's numerical like the output will be numerical here. Exactly, and it's continuous. So now any doubt? So I'll give you a sheet also in which you have to tell me which is classification, which is regression problem, which is unsupervised, which is RN. We'll do an exercise after completing this now only. Example. Yes.
Ma'am, in this classification, we do grouping?
In classification, grouping, no. Grouping is like clustering. You are saying about grouping. We are not grouping. We are predicting whether, okay, I'm giving you an image. It's like categories I'm giving you. I'm giving you an image like one. Now I'm telling like one can be written like this, one can be written like this, someone is writing like this. So I'm giving these images in the training data set. And these are the images, and this is the output. Output is 1 here. 1. Output is this. Now, if someone writes the 1 like this, the straight 1, now in the testing data set, I should predict that this is basically 1. This is not 2, 3, 4, 5, 6, 7, 8, 9. This is actually 1. So that is basically what is, classification. I am classifying it, giving these are the classes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Either I'm giving the cat image. I'm telling what is this? Which class it belongs to? Cat, dog, tiger, or elephant? It belongs to a cat class. Are you getting? Yes. Email is spam or not? It is classification. Ma'am, email is spam or not is like classification. Why would you take in supervised learning? Okay. So supervised learning itself, is of 2 types, that is classification and regression. If something is coming in classification, that is actually supervised learning only, na, Suraj? So that is basically classification. Any doubts now? Okay. And someone was telling me, can you give an example of regression? Yes. Can someone give the example of regression? I think Rahul was asking. Yes. Now can someone give? You told
linear
that
regression and logistic regression. Linear regression and logistic regression.
Again, I'll tell.
Maybe temperature prediction, ma'am.
Yeah, weather prediction.
Weather prediction. How, like, some input are given to me. Like, suppose I'm giving you the size of a to buy a house. I'll give you the size. I'll give you the location. These are the features given to me, and then I'm predicting the price. So, as you also said, temperature prediction, predicting the price of the house. Yes, exactly. Predicting the weight based on height. Exactly. So these are basically regression when the output is numerical in nature.
Political election.
Political election. How you're saying it? Yes,
मैम
this will be.
वो वोट काउंट करता है ना वो रिग्रेशन से.
But what we are predicting, how is it learning? It's just the counting, na?
कि वो
salary prediction?
कि वो जीतेगा कि नहीं जीतेगा.
Share market
Classification, na? जीते या नहीं जीते, that is classification.
Ma'am, salary prediction?
Salary prediction, yes, exactly.
Yeah, based on the experience, degree, or city, we can get the output as a salary.
Ma'am, stock market.
Yes.
Stock market ये जो fluctuations हैं इसको verify करने के लिए या predict करने के लिए हम कर सकते हैं regression का use.
Yes.
क्योंकि वो भी continuous values होती हैं.
Height versus
Ma'am,
weight
house
chart.
price prediction is also one of the example of regression.
Yes, exactly.
Based on size, location, and bedrooms, we can.
Yes, exactly. Let's proceed. Unsupervised learning. Now, I think so. You guys know what is unsupervised learning? Yes.
Yes, ma'am.
जिसमें target features नहीं होते हैं.
Like here
Unsupervised learning is like
training the data with unlabeled input.
I mean, you got like
we just
unlabeled data, and you let the machine figure out by itself like which class particular data point belongs to, like
हम
just
बस उसमें
grouping.
डेटा फिट कर देते हैं, मतलब उसको डेटा प्रोवाइड कर देते हैं एंड देन वो अपने अकॉर्डिंग क्लासेस बनाता है और फिर उसके अकॉर्डिंग वो प्रिडिक्ट करता है चीजें.
So basically,
Absence of supervisor may be unsupervised.
So exactly, you all are correct. So basically, unsupervised learning is like unlabeled data, where we are not looking actually for I'll say outputs. We are not looking for the output. We are finding the pattern here. We are more interested in pattern.
Ma'am,
So-
here the model find the patterns or a structure or any kind of relationship in the input data.
Yes, exactly. So we are actually finding the pattern. This is of basically two types. In training, we are not giving what is like mapping is not there. This Y is not there. So it's of two types, clustering and association. So clustering, can someone give me an example of clustering?
Grouping of similar type of like elements.
Yes, exactly. So grouping of similar
Synonyms.
elements. Yes. So
Look like yes.
BMI index.
Ma'am, maybe sentiment analysis.
Yes, exactly. Sentiment analysis. So basically, we are clustering them only, like how the emotions and all are. So basically, that is where the clustering. Basically, we are finding a cohesive group. So in which group, like in shopping mall, who are coming with in which group, who are
Yes.
coming, and if suppose if I talk about an simple honest like suppose I want to find an attacker here. So I have the honest client group, I have the attacker. Their behavior will be different. I can do the clustering. If someone is behaving as an outlier, I'll not use the technical words. If someone is behaving not as a particular cohesive group, so I can find out the attacker as well. Does it make sense? You all are correct. Customer segmentation, customer data. I'm giving you an example just out of box. Like if I want to predict an attacker, honest clients, honest devices will behave one way, an attacker will behave different way. I can find out by clustering. Does it make sense?
Yes, ma'am.
It
So-
kind of is.
Yes.
So, okay, Aryan has also given an example, good example, recognizing target audience for a right category. Exactly. Oh, for a YouTube category. Movie genre. Yes, you all are correct. Market. I'll come to that market basket analysis. Okay. So you all are correct. Now coming to association. Can someone, okay, this was just a grouping, finding the cohesive group. What is association? Anyone?
Ma'am, association is all about find the relationship or rules between items.
Yes, exactly. So if A comes, then B also comes.
Then B, yes. If A, then B.
Analysis, yes, exactly. Now it's like market basket analysis, exactly.
Yes.
Agitation.
Recommendation systems as well.
Okay, yes. Recommendation system as well. So probability of two people coming together, yes, exactly, Yansh. So if I say I buy bread in the market, so it's more probable that the user who buy bread will buy butter as well.
Yes, they buy jam too.
Yes. So now coming to measures, performance measures. So if I talk about some tasks, now we have learned about classification, just the intro part, not actually the regression, clustering, association. Okay. What is RL? Actually, I'll not go in deep in RL. If you want to know about RL in more deep, you can. I have the video lectures.
Reinforcement learning.
Let me complete. Okay. Yes. Sorry to say. So if you want to see in RL in more depth or so, you can see the YouTube lecture of mine. Like I have a whole playlist of RL also. reinforcement learning. You're absolutely correct, Sanchit. Can you tell me what is RL in more detail? This is just the full form. What is RL?
It's like reward and punishment based learning, like where the agent gets a reward if they perform an action right, and if they get a punishment if they work wrong. So then in that effect, they learn how to maximize their rewards.
Yes,
Ma'am,
exactly.
Ma'am,
like
it's between
our
both
education system,
supervised and unsupervised learning. It's a mixture of both.
Okay.
हम लाइक एजुकेशन सिस्टम बोल सकते हैं क्या इसको? जैसे
How?
हम किसी भी सेमेस्टर के एग्जाम देते हैं, फिर पास होते हैं, या तो पास हुआ या तो फेल हुआ, बट उसको सुपरवाइज करने वाले लोग भी हैं
But
ऐसे।
what?
फिर
कैसे? I
फिर वो रिवॉर्ड मिलता है उसको, मतलब वो पास हो जाता है, तो ये एक रिवॉर्ड है स्टूडेंट के लिए, ऐसा कुछ है क्या?
no.
मैम वो बार बार चेक करता है, फिर उसको एनहांस करता है, फिर चेक करता है, एनहांस करता है,
Like
ऐसे करता है वो।
I
cycling.
think
Okay, I'll give you an example of cycling. What is cycling? Is someone teaching you?
No, like a bit, yes.
Bit
Like
yes, but still
yeah,
it's like
overall no.
overall no. You'll fall down from a cycle
Yeah.
or you'll find the balance. I'll say. So if you'll fall down on a cycle, like suppose you're like a kid is basically like learning how to ride a cycle. So if a kid falls down from a cycle, so can I say it's a negative feedback? So kid know that okay, my balance was not fine here. I should ride the cycle like this. Then I'll not fall down here. So basically that is a negative feedback. Now, if his father claps and say, okay, you are riding it properly and he's finding a balance, which means he's getting a positive feedback. So actually cycling, you are learning by trial and error. You are making your mistakes. You're learning from your own mistakes. Exactly, Chetan. Exactly, Satwinder. You're learning, gain experiencing from your errors. You're learning from your own mistakes. You're either getting a reward, you're either getting a punishment, and you are learning from it. So there is a traditional example here, like a Pavlov dog example. So what's that example? So it's an experiment. It was done like a trainer, like a dog. The person basically rings the bell and serves the food every time to the dog. So now what happens whenever the person ring the bell, the dog will come and he knows that the food will be given to him. So the food is like a reward. So now the dog has learned that when the bell will be there, I'll be given a food there. So it's like a reward to him. So it's learning from the dog is learning from the feedback there. That is basically reinforcement learning.
Excuse me, ma'am.
Yes.
Ma'am, I wanted to ask that we gave the definition of classification and regression. So how can we differentiate between both the problems? Like if we are given a problem and we have to identify if it is classification or regression, how will we do that?
So you have to think that whether the output will be numerical there or whether the output will be a class there, whether the output will be categorical there, like spam or not spam. It's obviously that is a category. That is basically a classification problem. If I think, okay, I have to predict, like someone said me, you have to predict the price of the house. Obviously, it's a numerical output. So that's basically a regression there.
Okay.
We'll solve the worksheet also for that. Don't worry.
Okay, ma'am, got it. Thank you.
So if you want to go in detail about RL, so I have made the video lecture. You can see the first video lecture. You don't obviously this is ML course, so don't go in much detail because first try to go through ML first. RL, see the first video lecture only, and you can go. You can get the many concepts about RL. One more thing about RL. Basically, we are here learning the policy here. Okay, leave that. I'll tell you afterwards. Okay, so basically RL is basically trial and error. We are learning from our reward. We are learning by itself. That is basically RL. Now measures. What about task classification? I can say the measure is basically error. I'll write first of all the measures, then I'll explain. I'll explain each of them. Don't worry. So if I talk about error, classification or regression, I'm taking the measured error. There can be various measures as well. Like just an example to tell you how the performance measures are there. So what is error? How many, like I can say, first of all, can you tell me what is error from your side?
Like the difference
See,
between the actual and predicted value in a sense.
So can I say number of incorrect predictions over total
Yes.
number of predictions?
Pretty much,
Yes,
yes.
ma'am.
Yes, yes.
Yes, definitely.
Noise in data. No, not noise. This is basically, we are saying what is basically performance measure if I'm accuracy or error. So what is scatter? If, okay, we can take a client classification error, accuracy as well as many measures just to go through some of the measures. What is scatter? If I talk about scatter in clustering.
Scatter would be how much the, from the outcomes, how many
Deviate.
outliers are there?
How much we
the
deviate?
scatter of data points. Yeah, data points scattering around the
How
space.
spread out the data point
Yes,
within
yes,
a cluster?
It's like
How from
it is like a less distance between the elements.
yes, exactly. You all are correct. How much variance is there? How much scatter they are there? How much compact they are there? So that is basically scatter. Now, if I talk about purity, there is another like performance measure written here, purity. How pure each cluster is. What do you mean by how pure each cluster is?
like
How
there
clear
are
we are about our predictions, or how true are to our prediction.
Exactly. So, uh, how many data, like suppose I'm saying that it belongs to cluster 1. I have cluster means group, okay? Cluster 1. So, it's exactly belonging to the same cluster.
Most
That
common
is-
class.
So, that is basically purity. If it's actually belonging to cluster 1 and it is like how pure that cluster is. How many data points in the cluster? Suppose I have 5 data points. So, which means 5 data points are you getting, like 5 inputs I'm giving, and how many of them they are belonging to cluster 1. Actually I am predicting they are belonging to cluster 1. Actually how many of them are belonging to cluster 1? That is basically purity. But obviously for that you need to know the ground truth before only, but for scatter you don't need to know the ground truth. You got my point? That ground truth, what do you mean by that?
yes, ma'am.
His true levels.
No, madam. Can you please explain this concept?
Like, okay, suppose I'm predicting an email as a spam, okay, and now this is what I am predicting. Now we have one ground truth or actual truth, that actually it is spam. You got the point? Like, actually this email is spam or not, this is what I am predicting. So what I'm saying is these 5 points are belonging to cluster 1 of cluster 1. So actually these points are from cluster 1 only. My prediction is how much correct. That is basically purity.
All right, madam. Yes, understand. Thank
So
you.
the next is support.
Excuse
Yes,
me, ma'am.
yes.
Actually, for all these entire topics, whatever you are taking here, so it's all about the formulas part also. We are having each and every topics, we are having the formulas to calculating.
Yes,
Am I right?
yes. I'll
So,
come
may I
to
know?
that. I'll come to that in detail, but this is just a introduction. Like when I'll come to, I can say clustering part. Like then we'll go in more depth of scattering. Like obviously we are not today learning what is clustering exactly. What are the types of clustering? We are only learning the introductory part. Actually, you should know about. You should have some intuition behind that. What are the things that when we learn in more depth, then you will get to know. Okay, yes, we have done that.
Okay,
So
ma'am. Because inside that we are getting all the assignment question and all in the mathematical formulation mode only.
okay, that I'll come to. I don't think so. For this, you are getting the mathematical questions. I'll come to the
Okay.
maths part as well. I'll come to that, whatever is
Sure.
taught of the class. I
Sure,
know
sure,
that this is taught also in more detail. So
Okay, ma'am. Thank you.
maybe 1 hour 15 minutes are left. We have to buckle up, like we have to make. Ma'am, is this all week 1 portions? Yes, exactly. So okay, so what is support? So how frequently? I'll say I'll come to mathematical part in more detail, actually, more than appear in data set. So basically, how frequently each item is coming. If I talk about transact, like suppose I have items bought. This is transaction ID. Suppose number, these are only 1, 2, 3 items, like index, you can say, like bread, milk, butter. This is bread and butter, bread and jam, milk, butter, bread and butter. So suppose I want to find the support. The support is how often, how frequently item set, or I can say how often, if the question is both bread and butter are coming. Bread and butter are together bought. That is basically support. If I'm saying when both or 2 or 3 items are bought together, or 2 or 3 items are coming together. So what is support here? If I say how often do bread and butter are bought together? Bread and butter, bread and butter, and bread and butter. I can say the support is 3/5. If I talk about the other metric, confidence. Other metric is confidence. What is that? How often items in B appear in transaction that contain A. So basically, what is it? Like suppose how, like if butter is appeared, if bread is there, suppose, then how often butter is bought? So if bread is there, how many times bread is there? 1, 2, 3, 4. So 4 times bread is there. If bread is bought, then how many times butter is also bought? 1, 2, 3. So if bread is bought, then 3 times the butter is also bought. Do you got the intuition? Like if one item is bought, then how often the other item is also bought? That is basically the confidence. Support is when both the items are bought how many times. Is it clear? Should we proceed?
Yes, ma'am.
Okay. So if you'll have any doubt,
Would you tell confidence again? I missed. I couldn't understand it. I understood support. It's 3/5, but confidence.
confidence is, I'm saying that one item is bought. I'm saying that bread is bought. Then how many times butter is bought? First of all, how many times bread is bought? 4 times. Out of 4 times, when the bread is bought, then how many times butter is bought? 1, 2, 3. So 3 out of 4 times. So if one item is there, then what is the probability of having the other item out? That is basically the concept.
Okay.
Let's go to the supervised learning in detail now. Before that, obviously, we have some factors like challenges, also noise and all.
Ma'am, will you share this note to us?
Yes. I'll share the link of the drive to you. Maybe
Okay, thank
the YouTube channel link, description itself. Don't worry. So if I talk about supervised learning, we know that supervised learning is like we have discussed in much detail. We have the label data, and we have the input output mapping here. That's what. Now one example was given in the class as well. Like we have to predict whether the person will buy a computer or not. So there was some metric like age and income. So what was there? First way, if the income is less than some value, we are saying that the person will not buy. Okay, sorry. If the income is more than some value, we are saying that person will buy. This was the first metric. Like what we are doing, we are having a decision boundary. This is called a decision bound. So I have some income. Suppose what I am making. Sorry if I am doing some hurry. Okay, let's. I have two features. Suppose age, income. Suppose I'm making a rule. What does machine learning do? Suppose they are making a rule. They are setting a decision bound. What they are saying, if the income is like suppose less than 50,000 per month, that person will not buy. If the income is more than 50,000 per month, that person will buy. So they are basically making a decision based on the income attribute. Can I say that is done? Now there can be a decision based on age attribute as well. Now what can be there? Can anyone tell me? I have two features, age, income. These are the input given to me. For more clarity, output is buy or not buy. First of all, I took a simple model. What I said, if the income is less than X, the person will not buy. If the income is more than X, that person will buy. Now let's take more factors. Should we take more features first of all? Is it beneficial for us to take more features? Can someone tell me?
It
Yes,
will
ma'am.
be beneficial in this case because age is also something that determines if you're gonna buy a computer or not. For example, if you're below a certain age, you won't need a computer. If you're above certain age, you will need a computer anyway. So
This can be also a factor, or one factor can be if you are above the certain age, you'll think like your income should be more. Then only you'll buy. If you are below the certain age, not a kid, I'm saying, if you are within a certain age, if your income is less, also you'll think, okay, I can buy. So there can be certain rules for that. It can be made for that. So this is how. One more thing, like you said one point that yes, the features can help. Like this input features can help. These are the features. These are the features I'm giving it. Like should these features be very less or very more?
We can add occupation too.
Okay, not talking about this example. Generally.
Ma'am, generally, even if we are adding more features, there should be, sufficient amount of features that do not affect the decision of the algorithm, so that it does not confuse the algorithm.
Okay.
Ma'am, if you consider the more input parameters so that we can predict like almost accurate outcome.
Okay. What about others? This is a very important point.
sometimes if the number of inputs exceed a certain limit, the computation will be a bit slow. So that is something it might.
Leave about computation. What about prediction?
That will be a bit messy, right? Like too many factors to consider will be a bit hard to learn for some. Some it might work very well. For example,
You all like yes, there can be like, but why it will not work? Like you all are saying that there's not much features. Okay, it should be more, but not that much more. Can you term one thing which I am thinking like what it can be?
The features we are taking should affect the buy or sell ratio. Like it should affect their mindset that they are going to buy or not. Then only then the factor will affect our prediction.
Should be statistically
मैम
significant.
मॉडल ज्यादा सेंसिटिव हो जाएगा ना, और साथ में आउटलायर्स बढ़ जाएंगे बहुत ज्यादा, तो मॉडल को दिक्कत होने लग जाएगी, तो फिर वो अच्छी तरह प्रेडिक्शन दे नहीं पाएगा. मतलब उसकी प्रेडिक्शन बढ़ जाएगी पर लेकिन वो बायस बहुत बढ़ जाएगा, ओवरफिटिंग हो जाएगी.
Yes, Medha. Yes, exactly. What is overfitting? I have termed one thing overfitting.
ओवरफिटिंग इज जब हम सारे जितने भी पॉइंट्स डेटा पॉइंट्स हैं उनको अपने फंक्शन के अंदर कवर करने की कोशिश करते हैं.
So overfitting is when you give a training data and the machine algorithm or the machine learning tool fits it so nicely that if you now give the normal data set that you want to check with, it'll miss all of them.
Yes, exactly.
Overfitting is all about training data too well, but including the noise, errors, or outliers and all, and it performs poorly on test data. So this is
Yes.
called overfitting.
Yes. So we are trying to fit each and every point, as one of you said that overfitting is like, you all are saying exactly the same thing and exactly correct. What if I give you a simple example? If someone don't know about overfitting, I want to predict a ball. Okay, that the thing which I'm having is a ball. What I say that it's spherical in nature. Okay, it's used to play. Okay, it's orange in color and it's having lines in it. Is it correct to give this much of feature? Okay, Sam, sure. You can see the recorded video. Others, okay.
Ma'am, we can take an example, simple example, like suppose when a student who want to memorize the answer to the past exam question, instead of understanding the particular concepts, so they score high in the practice but fail in the real exam, and that's a really overfitting.
Okay, yes, exactly. What about this one?
You want to predict a ball?
These are the features I'm giving. Now, if I'll give orange, okay. Is this overfitting? Because if I'll give red ball in testing data set, the output will be, no, it's not a ball. Because what training data set has learned that the ball should be orange in color. So we are giving the extra noise as well. We shouldn't fit each and every point here. That is what my point is. Yes, Preetam, why no? Okay. Everyone got it? Now a simple example of underfitting. If I say, if I say that if I'm giving very less features, like if I'm saying an object with spherical in nature, it's a ball. Now if I give orange fruit, I'll say yes, it's a ball because the object which is spherical in nature, it's a ball, which means I'm giving very less features. Here I'm not giving sufficient data, sufficient features, to less learning parameters exactly. So here I'm trying to fit each and every parameter, each and every feature here. Here I'm giving very less. That is underfitting. So it shouldn't be underfit as well as it shouldn't be overfit as well.
Ma'am, it performs poorly on both training and test data, both.
Yes, I'll come to that. You are correct. It performs poorly on training and testing. That performs poor in testing only. I'll come to that. Don't worry. You are exactly correct though.
Ma'am, now in this example, it works best by using underfitting, no ma'am?
Is it working best by underfitting? I'm giving a spherical nature. I'm giving an object spherical, and then in testing data set, I'm asking an orange fruit whether it's a ball or not. Now I know that it's a spherical. I know that it's a ball only. I'll predict it wrong, and I'll predict the orange as ball. So that's also correct. Huh? How do you know about enough data or not? Uma, we'll come to that thing also in further lectures. Don't worry. So you got the concept. You all got the concept of underfitting and overfitting.
Yes, ma'am.
Yes, ma'am.
Okay. What is inductive bias? What is inductive bias?
Bias is I know bias. Bias is when a machine makes the
What is inductive bias?
Ma'am, it's a set of assumptions to learn an algorithm to make a generalize from the very limited training data.
So basically, we are
prediction on unseen data.
Yeah, it's a kind of set of assumptions. We can assuming something.
So we are learning the algorithm from the to make a generalized beyond the training data.
From limited training data, you can say.
Yes.
It is like towards the favorism.
So read about this inductive bias, language bias, and search bias. I'll not go in detail. Read about these. Maybe we'll discuss in the next. I can ask you in the next lecture. Like, not just go through this. What is that? So applications, examples we know. Coming about the regression part in the supervised learning, you know that regression is basically continuous in nature. Its output is numerical. So if I'm giving a time of the day, you have to predict what is temperature. As everyone was saying, predicting the temperature is a regression. Absolutely correct. And you know about overfitting and underfitting as well. Okay, if I talk about just giving an intro about linear regression. Giving an intro, like what is linear regression? Just as a part of regression. We'll come in next lecture in more detail. What is linear regression?
Ma'am, linear regression is a supervised learning algorithm we use to predict a continuous value based on one or more input features by fitting a straight line to the data.
In linear, yes, exactly. So we have two factors, like dependent variable as well as dependent variable.
Dependent variable.
What is independent?
Like input, ma'am.
Okay, yes. Like if I say
मैम इंडिपेंडेंट वेरिएबल फीचर्स होते हैं, डिपेंडेंट वेरिएबल टारगेट कॉलम होते हैं जो डिपेंडेंट वेरिएबल के ऊपर डिपेंड करते हैं.
Yes, Aditi, you can also get the copy. I'll share you the link. Don't worry.
The intercept would be the independent variable, but I don't know how it will work in machine learning.
Let's come to that also. If I talk,
doesn't affect the another.
Yes. If I talk about profit and loss and annual sale, like what I'm saying, I want to predict the annual sale. I'm checking the independent variable, like what was the profit, what was the sale. That is basically dependent variable. This is basically dependent on the dependent variable. The sale is basically dependent on what was the profit and what was overall loss there. So this is an example. What we are doing here is here in linear regression, we are modeling a relationship between independent variable as well as dependent variable. So why its name is linear? Because as x increases, as the input increases, the y also increases. So basically, or they are proportional in nature. Linear in nature, they are proportional to each other. I can say that. We'll come to linear regression in the next lecture in much more detail, talking about that. This was just an intro. What is linear regression? So talking about unsupervised learning. Now you know what is unsupervised learning as well. It's basically unlabeled data, no labels are given and everything. Clustering and association, you know about that. What is clustering, what is association? I don't think so that you need to know. I think so. You know much about that. Is it fine? Okay.
Yes, ma'am.
Okay, because we don't have time, maybe you can take a screenshot of this in the next lecture. Tell me the answers. Think about them. Or if you will have any doubt in any of them, ask me in the mail or ask in the comments in the YouTube itself. Or one more thing, I was thinking to make a Slack channel. Okay. Is it visible to everyone? You can take photo or screenshot of that. So what is the exercise here? The exercise is like you have to predict which type of learning is it. If it's supervised, what is the subtype here? And if it's unsupervised, what is the subtype here? I was thinking to do in class only. If we'll have the time, we'll do, but I don't think so we'll going to have, because now we are going to come to statistical decision theory.
Ma'am, in subtype, what we need to mention, ma'am?
What?
Subtype means like
Subtype.
in supervised, okay, whether it is classification or regression, that we need to mention. No?
Yes.
Okay.
For
What
your
are the subtypes for reinforcement learning, ma'am?
no, nothing. For RL, it's nothing. For supervised and unsupervised, we do have, but for RL, we don't have any subtype. RL, I'm not going to explain the RL in like here because we don't have that much of time. I have a recorded video, as I'm saying. You can go to my channel, see the first lecture of RL, you'll get to know.
I have just one question. When it comes to spams, is it supervised classification or unsupervised clustering?
It is
What do you,
When it comes to spam
what,
email,
what
is
do you,
it
what do you think?
pardon?
What do you think? What is your view? Why?
Well, technically, a spam email would be clustered into certain way, and then it would be removed, and the other way it would not be a spam, would be another cluster. But then,
Yes.
in order to make it learn, it would come in classification.
Yes. So, if I talk about, that's why I've written here why as well. Like, if I talk about spam, a very good question. Like spam, if I'm giving X and Y label here, like I gave email one and I tell them that this is a spam. Obviously, then I'll say it's a classification and it's supervised. If I don't have a label, I have to I can do cluster as well, as you said that. Okay, I'm seeing some words like so some fraud words something like some keywords which I'm seeing which are in the spam. I'm clustering them together. That can also happen here. So we can do clustering as well. So I think it can be taken in both of supervised as well as unsupervised.
Madam, if we are doing both regression and clustering, will repetition of the answer of a particular sample data, if it's present in two different categories, does it improvise the quality of the prediction?
We can't do both. If I'm given with the output as well, so obviously I'll do the regression only now. If I'm not given the output, then let's do the clustering. Let's do the unsupervised learning.
Okay, ma'am.
Don't worry. If you have any doubt, we'll come to that. And in further, we'll go in more depth. You'll get to know. Will this assignment? No. It's not any grading. It's nothing. I was going to discuss in the class only, just because we don't have much time. So I thought, okay, let's give you for practice. Maybe in the next class we can discuss. It's for you guys.
If possible, we can discuss a couple of them and then we can proceed. Or maybe towards the end of this lecture.
Yes.
Not all, but a couple of them.
Okay, sure. So that you can get an idea.
Yes, some idea. Yes.
So what is this? This is discussed in the class in much detail. What is statistical decision theory? What is that? First of all, before jumping to maths part, everyone is saying, ma'am, you're not doing the maths and all. Okay, first of all, tell me what is this?
It's combine the data, probabilities, and to choose the best decision, or we can say best action, we can take it out based on the data and probability, and it's called as statistical decision theory.
Exactly. So basically, what we are doing, what does that says? How good or bad I can say?
So based on decision, suppose these kind of action we can choose, like we have to we are getting the approving the loan or rejecting the loan and all.
So what is statistical decision? As you said that how is the prediction and all. So how good or bad is the prediction, or how to choose the best function for the prediction, that basically comes in statistical decision theory. Why we are doing is we want to know that how good our prediction is, which is the best function for the prediction. That is why we came up with the statistical decision theory.
Yes.
Are you writing? Are you guys writing side by side or listening only?
Yes, madam. Some points, at least I am writing, even though you are giving.
Just write side by side because it's a math part. Maybe you may get confused. Yes, okay. So, though I'll give the written notes, don't worry, but still, okay. This is suppose the input x belongs to R P, which means x is drawn from p-dimensional real space. I'll come to that also. What do you mean by p-dimensional real space, anyone?
It's a matrix. Real space would mean all of them are
Okay, that is
whole
real.
numbers and positive.
What is p-dimension?
P-dimension is matrix, so n into n matrix, so p into p matrix.
If I talk about like age and income, there were 2 dimensions which were given to me.
Okay.
You are correct only. Just an add-on, like input, what are the dimensions, what are the features which are given to me, how many of them are given to me. That is p dimension, how many of them are given to me. Y, it is y belongs to a real number, which is an output. And f of x, let it be a predictor function. Now, what is the main motive? Our main motive is we want to choose the best fx. What is this predictor function? With respect to x, I'm predicting some f of x. I'm predicting some f of x which should be near, which should be close to y, which should be close to actual output. Can someone explain what I'm trying to say here? Have you got it?
Yes. Ma'am, predictor function takes input features like x and produce an output like y. So y equals to f of x.
I suppose you have an x and you have a graph x and y. X is the row, y is a column, and x is the input and y is the output.
So basically, it's like a function. I'll go in like predictor function. It's something, I'll say in easy words, it's a rule or formula, like we were setting that, okay, it's less than this much, it's the best function. Exactly, Anshu, right? So it's like rule or formula which is taking an input, that is taking input
and producing the output.
And yes, exactly, and giving the predicted output. And that output, we want that function should be accurate, that we want that the error should be less, so that the like it should minimize the gap between this y and the predicted output. And there is an underlying distribution. Going with very basic. What is distribution? What is distribution? Have you thought? Simply, which is the probability of different outcomes. Probability of having an head is 0.5 when I'm tossing a coin. Probability of getting a tail is 0.5. So what I'm saying here, there's an underlying joint distribution. What is joint distribution? Can anyone tell what is joint distribution, which is unknown? That I'll come to that. So I have an input, I have an output. I want to predict a function which should be best function, which should have yes, combined probability, absolutely, which should exactly give me the y which is close to the actual y. So p of like suppose if I say joint distribution, which means like suppose I say p of xy, which means, or I can say in easy language, how two variables are behaving together. That is basically joint distribution. So how likely x is coming and how y behaves when x is given to us. Probability of one variable depends on this. Exactly. So that is basically how these two variables, they are basically behaving together. That is basically joint distribution. I'll come in more detail mathematical part, don't worry. So joint, they are
probability of two or more random variables occurring together is called joint distribution.
Absolutely correct. So if I talk about, so what we have a predictor function, input, output, joint distribution. Now what we are doing, we are drawing the samples from the training data set, that what we have learned earlier also. Like suppose this is a training data set, we are drawing the samples. We are learning it. We are predicting a function. and then we are basically under some joint distribution. Can someone tell me a simple formula of joint distribution? What is the formula of this joint distribution?
P of x.
P of xy, what is the formula? Okay, what is conditional distribution?
Conditional distribution.
Probability.
Probability divided by
P of x and y upon
probability
P
of
of
P of y given x
That is base.
px
This is simple. This is
base, right?
probability.
that is this is simple conditional probability.
Ma'am, divided by probability of x.
Why? Because I have written reverse. That's why you are confused here.
XY. Yes. Yeah, got it.
If I say actually it should
Y
be
and x. Yes, got it.
now it's correct. I can write both ways. Like now I have to predict y, that is output.
Yes, ma'am. Y.
So this is conditional probability. So this is marginal distribution. This is a joint distribution. I think now why the class only 2 or 3 are speaking, maths is started. That's why. Okay, simply, if you have any doubt, this is a conditional probability distribution formula, and this we have derived a joint distribution. This is basically a joint distribution. How when x and y behave together? What is this? Is it correct? Should I proceed?
Ma'am, which one is joint distribution? You said now there are a couple of, so this P, Y, X, this one is it for joint distribution?
This is joint distribution. This is just derived from that only, above only, conditional probability only. So what I'm saying is how x and y are behaving together. What is this? If x is given to me, how y is there? And what is the probability of x? First of all, what is the probability of x occurring? Then if x is given to me, what is the probability of y? What is this? What is the probability of x? First I'll find out. Then if x is given, this mark is if x is given, then what is the probability of y? This is actually the joint distribution. How they two are behaving together.
Okay.
Should I proceed?
Yes.
Ma'am, can you explain once again this one, these two equations?
Okay. So I have conditional probability. What does conditional probability say? How do we read it? What is the probability of y if given x?
Okay.
Given x, what is the probability of y? So it's like probability of x and y together, or we write comma here, x and y together, how they behave, what is the probability of having them divided by a probability of x.
Okay.
Now this is the joint one. If I say what is the joint distribution, I'm multiplying this by this. So what I'm saying, what is the probability of having the x? And then if x is given to me, then what is the probability of y? That is how that is what is the joint distribution. Is it fine?
Yes, ma'am.
Still you have doubt, mail me. I'll share some notes or something with you.
Just one question, ma'am. If you're talking about joint distribution, you're talking about how it's union in a Venn diagram, right?
Yes. Simply a joint distribution formula. Am I not audible properly?
No,
or my voice is low after?
You are audible, ma'am.
We can hear you.
Okay, it's fine. Okay.
Ma'am, last equation, ma'am. Last equation.
Simple, multiplying by this only. I've taken this p of x upwards, multiplying by this. Taken it upward, multiply with p of x, that is equal.
Okay, that understood, ma'am. Next one, p of x comma y equal to that. This one.
This is same. That is what I'm saying. Like p of x is multiplied by this, which is equal to this.
Okay. Yes, ma'am.
Okay, joint distribution. If you all are having some doubts, maybe we can go in within examples and all. Maybe I'll share with you. Don't worry about that. Okay, let's come to our main problem where we were. Now much of maths is going to come. We have some input, we have some output. Drawn input output pair is there. There is a function. There is an underlying joint distribution. So now, if I talk about a linear regression. So given training data set, training data, as we said, as I told, there is an independent function, there is a dependent function. So y bar is equal to f of x. There is a function which I am applying and I'm getting a predicted out. That is what a simple linear regression. Or I can say beta naught 1, beta 1, x1, beta 2, x2 till beta p, x. This x1, x2 basically it's same as like linear regression. We write a line like y is equal to mx plus c. The same way I have written here, mx plus c. X1 is like age, x2 is like income, x3 is like occupation, and these are basically constants. So how y will, what we were doing when we are given the x, when we are given the inputs, what will be the y? These are basically the coefficients, and these are basically like age, x is equal to, I'll say, age, income, and all of this. Attributes. I can write it as y bar is equal to fx only. Wait a second. If you're not getting, wait a second. V naught. Wait a second. Can someone explain this whole part, what I have written this much? Yes. Come on, fast.
Y bar is the y hat is the estimated answer. The estimated answer is what is coming out from the function f of x. After that, I need help.
So basically, y bar is equal to f of x. Like I gave an input x, applied a function, predicted function, and get the predicted output y bar. Fine. Now this is a linear regression formula. Like what we are doing here is, as I told you, like how we write the linear regression. That is, maybe I should have told you. This is the linear equation how we write. Maybe I'll tell you. Like this is how we write alpha naught plus alpha 1 x1, or I have written beta 1. I'll say beta 1 only, beta 1. Sorry. Beta naught. This is how we write a linear equation. Beta 1 x1, beta 2 x2, beta p x p, the last one. Now these, what are these x1, x2? We know that. These are like features, like age and income. Okay, fine. Now what are these beta 0, beta 1, beta 2? These are basically the
Intercept.
Intercept coefficients basically. What does it denote? Like suppose if I'm writing here y is equal to 0.8 plus 1 x1 plus 2 x2 plus 4 x3 plus 1.5 x4 simply. What does it mean? Like 1, 2, 4. Can someone tell me?
There are 4 inputs. 0.8 is the intercept on the y-axis, but I don't. And coefficients of x1 are how much it is contributing to the slope of the line.
Ma'am, x1, x2, these all are the input features. And
Exactly.
beta naught, which is the intercept, or we can say bias. Beta 1, beta 2, like 0.8, 1, 2, 4, and all, whatever the things is what, it's a slope, or we can say weights. And
Okay,
y bar equals to predicted value.
about the technical words, if someone is not understanding, can
Okay.
maybe, because I'm sorry for saying that, but some maybe here some are having the issue like to understand. That's why I'm saying, what is this 4y4 and y.8? What does it denote? Anything? Can I say this 4x3 is having more impact?
Yes, impacted.
So what
Yes.
do I here? I'm giving some features. I'm giving a feature. I have to predict an output. I'm giving the features like buy a computer or not buy a computer is an output. Income or age or occupation.
Yes.
These are x1, x2, x3. Now, if I say that income is the more prominent feature, that will how much each exactly, Meta?
Madam, can we call beta as a weight factors associated with each feature?
Yes. We also told the same. So how much weight or how much each one is basically contributing. So 4, obviously, if I'll say 4, x3 is basically income. So income is contributing more to the y factor. So that is carrying more weight.
More or
Is
less.
it clear?
Yes, ma'am.
See, in very easy language, I have told. And the same way, I have written here, like y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus, so on till beta p xp. Correct? P is basically dimensions. So total number of.
I have a doubt. On what basis do we allot the weights? On what basis do we allot the weights, ma'am?
Okay, that will.
I think there are probabilities also, madam.
Yes,
Can we
yes, yes.
So weight is based on probability of occurrence of this feature in the solution space.
Yes, exactly.
Thank you, madam.
Would you please explain what B naught is? I understood weights. I understood I understood the factors. I understood the weights. What does B naught help? How does B naught help here?
Anyone? Can anyone tell?
It's an intercept.
Y is equal to mx plus c.
C.
So what is c? Intercept. C is a constant.
Intercept. Or we can say bias as well, ma'am. Because
For
you
our
already explained the
example,
bias.
buying a computer is based on age and etc. etc. How does B not come in that? Because we have that's my question.
Can we
Age
call
in
it offsetting
equation
just
is
to be
x1 x2
considered?
x3.
Maybe when I'll come to this linear regression in detail, I'll explain you how I'll explain you the whole line y is equal to mx plus c. What is the slope here? What is the intercept here? Basically, intercept is where the line is touching the y-axis. I'll come to that from that
Sure.
example. So don't worry.
No, ma'am, actually, I know that this is a line equation and B
Uh-huh.
naught is the intercept. But how does it occur here? That's my only question. How
I'll
does
come to that.
No, ma'am, I still have the same doubt. You have x1, x2, etc. On what basis do we allot the weights, ma'am? Is there any funda behind it?
It's a probability only, like how much each factor is, how much. Okay, I'll come to that. Don't worry. I'll come to that how each probability or each weight is basically being assigned. I'll come to that. Let's
Yes.
think that okay, this is the factor. This was just I was telling you just to make proper understanding this example. Though I'll come to that how B naught. There are many doubts. Okay, let's check them. How this B naught, B1, B2 is assigned. What is this B naught having the role? This is bias and all. I'm not telling you because I'll come to that in now only. After, like maybe we don't have time, or maybe at the end of the lecture we'll discuss that. What is this bias and all? What is this intercept and all? Don't worry. I'm not explaining because of the reason, because so that you guys can first get a hang on this, then I'll come to those details. Till now, understood the intuition. Should I proceed?
Yes, ma'am. Could you remove that call this thing? You can still see
Uh-huh.
the screen.
Should I remove this example as well? Like
Example, there's a pop up right below for call. Like, yeah.
okay. So if I talk about this was a linear regression. Now if I talk about nearest neighbor. Can someone tell me what is nearest neighbor?
Yes, ma'am. So actually, nearest neighbor is one of the method to make a prediction by looking at the most similar data points, or we can say neighbor from the past examples or whatever past data we have.
So basically, if the data points they are close to each other, like suppose this is
Which is called neighbor. Yes.
Neighbor, yes.
Or we can say looking at the most similar data point as well.
Which are close to suppose I have to predict this +1. This is the x1. I have to predict it. So what I'll do, I'll pick up the 3. Suppose k is equal to 3. Nearest k, nearest neighbor. I can take the k. Like suppose, hi ma'am, so I feel this new. Can you please see this? Okay, I'll come to that. Don't worry. So I want to predict this x. So I'll see which are the neighbors, which are close to this. So x3, x4, x5, these are close to this.
Yes.
So what I'll do, I'll see what is the like output for them. Like suppose I have y3, y4, y5. I'll take the average and I'll say that is the predicted output for my him. Is it fine? Are you getting a just like intuition of it? Like what is happening? What I'm doing is taking the neighbors, what are the output of them, taking the average of them. That's it. We'll go in much detail in coming lectures. We'll also do the code part also. I'll try to do that also practically also. Don't worry about this. So that is basically k nearest neighbor.
Ma'am,
Okay.
actually, it's
Can
work
we
like
take-
first of all, we have to calculate the distance. Then we have to pick the k neighbors, like you are taking a 3, but and then majority of the people's whatever like we have to choose the level that most neighbor have. So this is the things we are having for the k neighbor, k nearest neighbor.
Can someone tell me what she is saying and what I'm saying? What's the difference? Yes, come on. You guys are getting. If you're not getting, please tell
So
me on my
in regression, we just check the distance between the point and the nearest point once, and in KNN we take a average of closest points.
I'll come to you. She's also right. I am also right. You're also right. What is happening is, yes, you which how we get someone is asking data set and calculating the distance from the data points, like Euclidean distance or any distance point.
Yes,
This can
calculate
happen. Now what she's saying, okay, you can take, okay, x3 denotes by 3, x4 denotes by suppose x4 also says y3, x5 says y2. So majority is y3. Your answer should be y3. Why you are taking the average? She's asking this. There is one thing called regression. There is one thing called classification. Classification is, I have classes y1, y2, suppose. Now, in classification, if suppose x3, x4, x5, they two are predicting y1 and one is predicting y2, I'll say my x, which is the testing data point, because the majority are predicting y1, so it should be y1, as you said. Now, the other part is a regression, which is a numerical value. So this y is here numerical, y1, y2, y3. So here, what I have to do? Here, I have to take the average, y1 plus y2 plus y3 divided by 3. Are you getting my point?
So for
Definitely.
No, ma'am, no.
Went, like
Can you
above your
please
head.
repeat this, ma'am?
It went above your head, or it makes some sense?
No, ma'am. Can you please repeat this, ma'am?
Okay.
just
So,
repeat the classification
sure.
once.
Now, yeah, I was talking about regression thing. I have k nearest neighbor. I have some data, this one. Okay. And the other data points are this. x3, x4, x5. These are its neighbors. Other are far. I said, okay, the neighbors are this. K is equal to 3. I'm taking 3 neighbors. K is equal to 3 means how many neighbors I'm taking? What is regression? What is classification? Regression means it will give me some numerical value, 0.2. x4 gave me 0.1. And x5 gave me, what is the output of x5? 0.3. So what should be the output of my x? I'll take the 0.2 plus 0.1 plus 0.3 divided by 2. 3, sorry. This is a regression case when I'm doing k nearest neighbor. Now she said, why you're not taking majority? Majority will come in classification. If I have k nearest neighbor in classification, I have x3, x4, x5. x3 says that it's true. It's a spam email. x54 says it's a spam. x5 says it's not spam. So what I'll predict for it? It's a spam. I'll go with the majority. So I can't take average here. Huh? And there I can't take
Ma'am, sorry, ma'am. For regression, what is in the denominator?
Three.
That's not clear.
Sorry to write like this. It's average. So basically,
Yeah, thank you.
Okay, so regression is for like supervised learning, but continuous. And you're saying classification would mean just taking majority ones. Got it.
yes. So it's like k nearest neighbor I'm doing. How I'm doing by regression, I was going to tell you about classification afterwards. As she mentioned, why you're not taking majority. So that's why I mentioned now only. Is it clear? Who was asking? A girl who was asking me?
Yeah, ma'am.
You were also right on your part, though we were discussing regression. So that's fine.
So basically, madam, just to clarify, nearest neighbor, it depends on, it basically depends on the kind of problem statement If it's a regression problem statement, then we have to use the regression kind of approach. And if the problem statement is classification, then the classification whichever has the
Yes, exactly.
maximum. So that approach depends on the problem statement.
Yes, yes, exactly.
Thanks.
So
Okay,
now,
ma'am.
yes.
Okay, I want to ask you that
Yeah.
after getting the average of K nearest neighbor, what is the next step?
Okay, what is the next step? That is
Yeah.
what, like suppose I want to predict the Y for the X. Like what should be the Y? What should be the output for the X? That is what I'm doing. I'm basically taking the average of the neighbors and I'm saying, okay, this is the output. I'm predicting the output. Then they'll be testing and all and everything. This is just a prediction thing, like how I'm predicting. Though I'll come in detail with the K nearest neighbor also. This is just a glimpse of what I'm teaching today is the introductory lecture, how the things behave.
Okay, thank you.
So coming to the loss function. So I have one true output, as we mentioned that, okay, there is a true output and there is a predicted output. What we want that the gap, the loss function, it should be minimized. The gap between them should be less. Whatever we are predicting and whatever the actual output is, it should be the gap between them. It should be the less one. And the most popular one is the squared error loss function. Though we'll go to, learn about the different loss function. One is the squared error loss function. And the performance, what we are interested in, expected prediction error. That is expectation by. So the expected loss function, the expected error, predicted error, that is what we are doing. Sorry. The square should be. Just taking the expectation here, nothing. Should I proceed?
Yes, ma'am.
What is the distribution which I am taking? That is a joint distribution. So now what I have written, anyone?
P of xy is
Integration.
probability of xy.
How I have turned the expectation to this thing.
Integration of y minus fx square
Integration,
into
And
into p of x.
how I came from expectation to this thing, that I'm asking.
Please tell, ma'am, we don't know actually.
I want that each and every point which is in the lecture should be understood. So, how do you write expectation normally in the discrete case? Expectation of x, how do you write? Okay.
Mean.
How do you take the average?
Mean.
So, like this. And
Sigma xi pi.
sorry. Sigma xi pi. I was like this. This is the average. This is actually the formula of average. 3 into 1 by 2 plus 2 into 1 by 2. That is what you are doing. X into P of X. That is what you are doing. Sigma xi into P of I.
Yes.
P of X, sorry. That is what you are doing.
No, ma'am, x square.
Yes.
X square.
Where square?
That's
Where?
for variance.
Not getting your point. Am I correct? Or I'm missing something?
Correct, ma'am.
Correct, no? Sorry. Sorry for the interruption. Summation x into px. Absolutely. So that is what. Now, when it is continuous in nature, we are taking the integration instead of the sum. It is discrete. That is why we are doing the sum here. When it's continuous, we are doing the integration here. That's what we are doing here. Y minus what was the expectation here?
F of x.
How we convert it? Integration into probability. Like x into p of x. Just in place of sum, we are taking the integration because of the continuous in nature. Because we are taking the regression case. Because regression is continuous in nature. And now p of x we are writing here because it's a joint distribution, both of them. So that is why I'm writing like this. Or in the lecture, maybe you may get confused. It's written like this. This is the same thing. I'm not writing like this. In the lecture, you'll see it like this only. So it's the same thing. This is the integration part, p probability of x dx dy. Getting it? Same thing, x into p of x, sum of x into p of x, integration of x into p. Okay, continue. Should I continue?
Yeah.
Yes.
What about others? I hope so. I'm making sense. Now, the most trickier part I want to ask you. You got that? Like simply, they jumped to this. How we came to this? Any idea? Like this was written before. Expectation of like this was written before.
No, ma'am, we don't know. We actually got lost.
What about others? Anyone got the idea? Like, okay, this is the equation which is written before. Sorry to write it afterwards.
Conditional probability.
How we came to this? This is first, I'll say, and this is second. Okay, this is basically the law of total expectation. First of all, are you getting? Should I proceed now? Is everything fine till now? Is everything fine? Getting it?
No, ma'am. No, ma'am.
Yes.
Please,
No,
from
ma'am.
integration onwards to
No
how
one
it
gets
comes.
integration. Got it?
Yes.
Yes. Okay. Now, I have to explain afterwards. This was expected. What expected error? We told, okay, expectation of the loss function. Okay, this is the squared error. Now we went to this directly. Actually, this is derived from, I'll come to that. I'll come to first basics. Then I'll jump there. First of all, I'll talk about law of total probability. Is it too mathy? Yes. No one is answering. Is it too mathy?
Ma'am, please continue, ma'am, because that's why we're here. We didn't understand it from the lectures.
Okay. So, probability of x is equal to x. So, summation of y, probability of x is equal to x, y is equal to y. How I have written this? So, this is basically a law of total probability. What I mean to say is, like, suppose x is the number on die. I roll a die, the number is 1, 2, 3, 4, 5, 6. This is the number. And the y, suppose whether the die is head or, fair or loaded. Loaded means buy side, right? I'm giving you a simple example. What is this basically? So x is basically number on die and y is basically whether the die is fair or, and y basic nature is whether y is basically fair 70% of time and y is basically biased 30% of time. So if I have to calculate what is the probability of x is equal to 3, the number of die which will come 3. So there are two possibilities. Either the die is fair and I roll 3, and either the die is biased and I load 3. Am I correct? Check this.
Yes, ma'am.
So
Yes, ma'am.
what is the What is this? Like probability of x is equal to 3 is equal to probability of x is equal to 3 and die pair plus, which means or. Plus means or here. Probability of x is equal to 3 and die is bias. So how I have written die pair and die bias is basically the y here. So how I have written this way only. Summation of y, probability of x is equal to x, y is equal to y. First go through it and then I'll give you 2 minutes. Read this. Have you got it or I'll explain again? Come on.
Got it, ma'am. It's
No, no,
like
it's clear.
x intersection die square. That expression.
What? Okay. Yes.
Is it same right, no?
Yes.
Okay. Got it. Thanks.
Should I continue? Anyone? So what I'm doing is I gave you an example just to understand the probability of x is equal to x. This is a law of total probability. We can write like this also. So that is what we have written. This is the formula used here. How, if you want to think, you can see this intuition behind this. Now this is a law of total probability. Now coming to this, I can write the same thing. I know the joint probability formula. So the conditional probability formula, x given y is equal to probability of x and y or probability of y. So I can write it as summation of y. In place of this, I can write it as summation of x is equal to x given y is equal to y multiplied by probability of y is equal to y. Just written like the conditional by conditional probability written this. Should I continue? Yes, it's marginal. Yes, ma'am. Should I continue? Now substituting to E of x. I'll again come to each and every step, don't worry. What is E of x?
Summation of x.
Now only we have done summation of x into x. I can substitute this. This is the probability of x is equal to x. Now only so substituting this. Please mute yourself if you don't have any doubt. Now, can I, like we can interchange the sum terms?
Yes, ma'am.
Order of summation. Just interchanging them.
E of x equals to x or y equals to y?
It doesn't depend on x. This term is not depending on x. Can I bring it outside?
Yeah.
Just doing some rearrangement, nothing else, don't worry. What is this term? Can someone tell me?
Ma'am, here p of x equals to, okay, yeah.
It's summation of x into p, summation of x into p of x, which means E expectation. Is it correct?
Yes, ma'am, it's correct.
It's correct. So now can I write this is also expectation summation of y into p of y into y. So basically I can write it as expectation of
X, y.
So this is what they have written. I'll come to this again derivation. What is this they have written? So expectation over x, like expectation of expectation. I'll come to this. I'll write it again. So this is basically, I'll say, this is simply this formula which I have derived. This is law of total expectation. That was law of total probability. This one,
Yes, ma'am.
the above one, which I told you. No? This is law of total probability formula. This is law of total expectation. I'll come to it again. Don't worry. Now again, I'll write these two terms so that you can get the hang over it. What is it? So what we are doing here is, this was the simple expectation of X, suppose. Now here, how we are writing it? Expected over.
Just one question. Why did we sum it in the first place? Why did we? I understood the expectation, but then we took a summation, and that's where it starts becoming complicated.
Yeah.
Why did we take the summation in the first place, or integration?
Integration, you're asking this one?
Yeah, why did we do that at all? Why did we do it?
Because we are talking about regression. And when we don't take the discrete values like 2, 3, 4, we are taking the continuous value. So instead of sum, we take integration.
No, I understood, but why are we taking sum or integration when we are trying to minimize?
No, this is an integration. Here I was deriving this sum by sum, this part, like how we came up with this formula.
No,
That is
till
what
that I understood, ma'am. Why you took the integration, because it's continuous. My question is why we took the integration in the first place when we are trying to minimize y bar is equal to minus f of x whole square.
Okay, just I was showing you about like how the integration, how we can do this, why we took integration. I was just showing you how we can basically decompose, like how we can write it in the other way as well. That was just nothing else. I think you guys may be getting confused. What is this? Or you got it? Should I repeat it?
Yes, ma'am.
I know. So, okay. This is the formula, expected prediction error. It's like expectation of y minus f of x squared. You got this. How we got this? So there is a formula, I'll come to that. That is expectation of x is equal to expectation. That is what I want to check. Is it it's x, y. Expectation over y, expectation x given y is equal to y. This is basically the formula. So if I plug in these values, this is the formula which is called as law of total expectation. This is what I have derived. So if I plug in these values, you plug in these values. So expected error f. Now the f is basically y minus f of x squared. So here that is this is expectation over x. This is the expectation y over x, maybe y minus fx squared, which is x here. This is now here. This is basically x here. Got it or not?
Here y were
Actually,
dividing by x, ma'am, last.
Not dividing. This is the conditional probability, like conditioned over x. So what I'm saying is, what is the expectation over the input? Then the expectation over the input given what is the expectation over the output here. So this is basically the formula which is used, which is called as total law of total expectation, and that I have derived here. Maybe I'll go to the derivation again. You got what is this formula? You got this. Just maybe I shouldn't have derived or so. Just to get you more intuitive. Like just I.
No, ma'am. We needed help. Thank you. We do need the help still.
Yes.
We
What?
do need the help. We do need the help. We require it.
So how we
Ma'am,
derive?
Ma'am,
actually
actually, simple formula also we have for these things, which is expected prediction error. And right now, whatever you mention it out at the last line, so it's using the conditional expectation, or we can say law of total expectation. We are making this as a formula. Am I
That
right, ma'am?
Yes, that is what I'm
Ma'am,
saying.
is it possible to explain with a simple example the same thing?
It's actually derived. Maybe I'll show you once again. Let's go.
Ma'am, can you please explain it from where you told us about total probability theorem? From
I'll
there
come
you
to
can
that.
explain it.
I'm not explaining that because maybe derivation, they all are getting confused. Maybe I'll come to that also. This expectation of y, what is the expectation of the output? What I am doing is, this is the law of total expectation. Expectation over x, expectation over x given y. This is basically the formula. Got it?
Yes.
Now, what I'm doing, I'm going to do this. Now, I have to do expectation over x, expectation of
Agora.
EP of f given x. Is it fine? Oh, sorry. Sorry.
Expectation
It's
y
fine.
Yes. Y by x.
Fine. Now, what is
Yes.
this? What is this?
This is y square minus y minus f of x whole square.
Now it's fine. Sagnik, now it's fine. Just a formula, plugging in the formula. Now I'll come to the derivation. Is it fine now, everyone?
Yes,
Just
ma'am.
plugging in the values in this formula, nothing else.
Yes, ma'am. Yes, ma'am. This part.
Now, how I got this formula, that is what I was trying to explain. So obviously you can't cram each and every formula, you should know, because this can help you further also. So coming to this law of total probability, I'm just writing this probability of x. This is a marginal, yes, Mayank, you are absolutely correct. We can write this like this. Probability of x is equal to x is sum of y. Probability of x is equal to x, y is equal to y. I gave you an example. Like if I want to predict that x is equal to 3 in a die, like what I'll do, I'll take each possibility of y and I'll take, okay, what is the probability of x is equal to 3 and the die is fair, plus what is the probability of x is equal to 3 and the die is bias. So each of the y, we'll take it and sum it up. That is basically marginal also. Is it necessary? No. It's not necessary to study the derivation. Actually, the derivation is not in the lectures also. I was just telling you so that you can understand it. No derivation is, this derivation is not at all there. Just because these concepts can come in future also, and you'll get confused like how these are there. So these can help you a bit in future.
Thank you, ma'am. Because actually, I was confused when I saw this. So that's why this was helpful.
So you got this law of total probability. What is it? Till now, it's clear.
Thank you, ma'am.
Okay, so someone
Yes,
is saying
ma'am.
there are too many derivations, so you don't need, like, what are your views? Like, I should tell you, or simply I should say, okay, this is the law of total probability, and we came to this.
No, ma'am. You can continue with whatever. We'll try. We'll.
Okay, I'll leave up to you. I have told you. I once go through it. Whosoever wants to understand, you can mail me or write on the YouTube channel. You can explain with simple example, not with formula. Okay, I'll come up with the example in the next lecture. Don't worry. Okay, I'll give you the end of the session. I'll tell you about the doubts and all, channel name and everything. So we came to this thing. Is it fine till now?
Yes, ma'am.
Yes.
So I give next example. So till now, any doubt?
Okay, I want to ask you
Yes,
about your YouTube channel. What is your YouTube channel?
the YouTube channel I'm writing in the chat box.
All right.
I'll upload these recorded videos, these recorded videos in the YouTube channel. You can look at them.
Okay.
So maybe like it's okay. We'll continue. Maybe I'll complete this. So like what I have to do, what is the main motive? I have to pick an f such that for every value of x, it will make the best prediction. That is what our main motive is. I want to have a predictor function such that the value should be minimum. That is the main motive.
Would you please repeat it, ma'am? What is what that ARG? What's ARG? Minimum, I understood. Minimum. But
I'm
what's
going to tell you, don't worry. I'll just written. Argument, I'll tell you. So now our main motive is I want a value. I want a function which should give me minimum loss function. That is, I want to choose that function which should give me the minimum. Now, what is argument? Anyone can tell me what is argument? A simple example. If I take the value 1, what is the value 4? If I take the value 2, what is the value 1? If I take the value 3, what is the value 0? If I take the value 4, what is the value 1? So what is the argument? What is the minimum value? 0. And what is the argument? Can someone tell me? Everyone has studied in the lecture. What is argument?
Ma'am, argument is an actual value we can pass into a function when we call it.
What is the argument here? What is the answer here?
Arguments are 1, 2, and 3.
Minimum loss for a particular argument.
So what is the I'm not asking anyone definition. Can you tell me the answer? Someone has written
One,
chat.
ma'am. X is 1. Argument min is 1.
Someone has written correctly in the chat. Everyone can see it.
Prima.
How? So what I am doing is minimum value, which is 0 here. But which value is giving me 0? Which x is giving me 0? 3. F of 3 is giving me this. So what I'm saying here is give me an value, give me the C argument, give me the point that which will have the minimum value, which will give me the least point. Is it correct? Maybe we'll discuss in the next lecture. We'll continue with the next with this in the next lecture. So before that, till now everything is clear. Like, how was the lecture? Give me an honest feedback. I don't want any just an honest feedback. How was the lecture? What can be improved in the lecture? Only MCQ should be there, or we are going correctly.
Ma'am, this is nice, but the maths part was very confusing in sir's lectures. So any problem solving that would help us with the maths part would be very helpful.
Okay. So is it fine going through like this, or like I'll come up with the problems, don't worry. At the lecture will be next Tuesday 6 to 8. I think I don't know about the other TA. I think someone told me they are also solving like this only, or is she going through this, or like this only, or she's solving the problems?
Ma'am, we had a lecture on this Sunday, last Sunday, and she was telling us the concepts only. And she gave us, she said that the questions are in PDF, in the PPT. If you want to solve them, you can go through it.
Okay. Maths part, they are not solving.
She was also out of time. She said she'd pick up the maths part in her next lecture.
Okay.
Ma'am, and these meet videos will also be given to us, no, ma'am?
Yes.
The
So
recorded videos.
YouTube channel, that is what I'm saying.
No, not the YouTube. We are having a meet, no, ma'am. Normally for the other NPTEL classes, these recorded sessions will also be given at the this thing portal, NPTEL portal itself.
No, I don't think so. Like, I'm teaching from 3 years in NPTEL TA. I don't think so. I'm not giving the recorded lectures to NPTEL. I'm only uploading on YouTube.
Yeah, but normally in every class it will be given the recorded sessions.
I don't think so because I have taught for RL course, computer networks, probability. I haven't given for any of them. Okay, maybe I'll this time. Maybe I don't know. Maybe if they'll ask. Otherwise, you can see there, and you can mail me. And I think so. This lecture, I have given my 100% to you guys. Like I think so. It was a good one. I don't know. Give me the real feedback. Is it
Could you please suggest some source to get practical knowledge, like to get
practical
practice to?
Oh, okay. When I'll come to because this was the introductory video only. Like we are not going in the more of I'll say detailed one. When I'll come to that practical thing, I'll also give you the source like linear regression. When I'll teach you, I'll code also. I'll try like I'll do the coding part as well, so that you should have the hands-on practice as well. Is it fine? Because these are the first week videos where they are being taught what are the things basically what is linear regression. We are not going in much detail about them. But when I'll go in what is linear regression and all in the next lecture, I'll try to do hands-on practice as well.
Okay,
And problems at KNN at the end of class. Okay, KNN will maybe in the next coming lecture that will be also in detail. Ma'am, are you from Tirupati? No, actually I'm studying in IIT Tirupati, a PhD scholar.
Ma'am, can you also please suggest us some sites or some place from where we can study math properly? Like if we are not getting whatever it is provided in the NPTEL videos, I mean, if we are not getting what it is there in it, can you please suggest some other resources as well for better understanding?
Maybe there is a book mentioned there in the SWAM portal itself. I think the professor is following that book only, the first book which he has mentioned. I forgot the name itself. You can see that he's following that book only in detail. In that book, mathematics part is shared in detail about the scale and everything. You can go through that. About the lectures, I can't name that here, like obviously.
Okay, ma'am.
And
Is
if you
there any YouTube channels to give this practical knowledge parallelly? Like
that's I'm saying like when we'll do the like practically, I'll also try to solve this linear regression, everything practically. When I'll also share you the other platforms as well from where you can learn. Don't worry. This is just the introductory part. Like what is this? What is this? What is this? How the things are working. When we'll go in depth, like what is linear regression, then we'll solve hands-on.
Ma'am, when will we have the next lecture from your end?
Yes, yes, sure. Yes, what you're saying?
Ma'am, when we are getting the next lecture from your end?
Tuesday, the same time next week, 6 to 8 Tuesday.
Okay, 6 to 8. Will we have the practical questions in exam as well?
No. How you can have practical questions? It will be written only.
Ma'am,
Yes.
I want to clarify that these formulas and equations, how they relate to machine learning. Why we need to study these formulas and equations?
Why we need to learn?
These formulas and equations.
Actually, these are the basics of the machine learning, which the maths behind the things which are happening. Like if I talk.
You mentioning the variable x, y, what is actually on the machine
When
learning?
we'll do the practical thing, when we'll do the linear regression and hands-on, then I'll tell you like where these things are we are getting.
I'm just an easy student. I can't understand what these are all, how it's related to machine learning, why we are studying this type of
Why we are
probability.
okay. Why we are studying this maths, you'll come to know in the coming lectures. I'll do the hands-on practice, then I'll use these things in the hands-on practical coding. Then you'll come to know. Don't worry.
Okay.
Every Tuesday, share us the book name. So it's in SWAM portal. You can see that every Tuesday. like there'll be 12 weeks. If if the syllabus will not be completed, I'll take 1 extra week as well. Don't worry.
Okay.
Thank you, class. And still you have any doubt? Yes.
Ma'am, were any assignments given in the 2 weeks?
Yes, they are given. Check the
Ma'am,
portal. Week 1 now. No. Submission date, I think it's in August only. Don't worry. I think
Okay,
so.
ma'am. It started from 21st
On
July.
6th of August, the assignment date submission is last date.
Yes.
Okay,
Thank
ma'am.
Thank you,
Ma'am,
ma'am.
will there be any this live classes also this week or next week?
I think on Sunday other TA is conducting.
Okay.
From that is manager, I was for
Thank
Thank
you
you,
so
ma'am.
I hope so. The session was good. Thank you, class.
Yeah.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.